All right. Hey kids. So I'm not here today. It's Monday, and many of you are staring at me right now. But you should have your Chromebook out. You should have your worksheet that the sub gave you, and you're just going to take notes and you're going to follow along. Now I'm going to talk very, very, very fast, but you have the ability to pause. Go back and replay it at any time you want. All right. Once you start to understand this, you can possibly speed it up, but I would recommend that you just go along with the material, even if you feel like you're going ahead. Okay. I'm going to show you the answers to last night's homework. You can pause and look at those, but again, those are in the back of the book, but you can check those really, really quick, okay? So there's 1, 2, 3, 4, 5, 6. If you were to put 1/2 in for number 5, if you were to make this like 1/2, that's fine as well, right? Um, and then here's the back side, 1/3. If you put 0.3 repeated, that's fine, but I like 1/3. 1/4, if you put 0.25, that's okay. And then there are your last two. Again, all of them are in the back of the book, but just make sure that you're checking your answers and you understand what's going on. If not, you can go ahead and ask questions on Tuesday when I come back. All right. So here we go. So today what we're going to do, we're going to recognize that sequences are functions. So you're going to look at a set of numbers and determine that they're a function. And then you're going to use the explicit formula that we've been kind of going over, which you actually already know. It's linear and exponential formulas. All right, so that's really not new. But this is going to be the new thing right here, recursive formula. All right, so you're going to know how to use it and you're going to know how to write it. Okay, so that's the big thing today. Can you use it and can you write it? So here you go. Here's your the notes for today. So we're going to talk about a sequence. So parts of the sequence. Well, there's two parts, right? There's a term number, and then there's a term value, right? The term number is where a number appears in the sequence. So a term number, all right? A term number are these right here. You see this A1, A2, A3, A4, A4, A5, A6. That means the first number in the sequence, like first number. This means second number, and so on and so forth. All right, that's called your term number. Your term value is the value of the number in the list. So the value, the first value is 1, then it's 3, then it's 5, then it's 7 and 9, and so on and so forth. So that's the value, but the term number is the first number in the sequence, the second number, the third, the fourth, and the fifth. All right. Now, the fourth number in the sequence, if you looked at this sequence right here, the fourth number in our sequence is 7. 5, all right? So now look here, 5. So it's right here. 5 is the third term, also known as A3, all right? And now lastly, what's A7? Well, if you see A7's not here, but you can figure it out. We have A6 and A7. So I will actually write this on my paper. A1, A2, A3, all the way. So if you notice, there's a pattern. 1, 3, 5, 7, 9. It's going up by 2. So 11 and then 13. So 13 is your 7th term. And that's what we're going to kind of be working with today. So here we go. So we actually have been working with these types of functions for a while, all right? And they're called explicit functions, all right? Explicit functions basically tells you what you're doing, where you're starting, and where you're going, all right? So this right here, this first right here, is called an explicit linear function. And you should be able to look at this and say, hey, that's linear, because this is my slope, or my m, and this is my b, right? Or my y-intercept. So I'm going to start down 1, and then I have a slope of 2, or 2 over 1. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Connect my line, and I go down to left 1, down to left 1, down to left 1, down to left 1, and connect my line here. That's just our line. You've been doing that since you were in 5th grade. So now, looking at this, let's answer some questions. Is it continuous or discrete? Well, it's continuous because we have a line, and we put a line because you can put any number you want here. Our common difference, or our slope, is 2. And the domain is all real numbers, and our range is all real numbers, because you can literally have any point, any decimal that you want, and that's because you have your line. Now, Over here, to your right, this is called an explicit arithmetic formula. And you don't really know what that means yet, but arithmetic means that you add or subtract to get to your next number. So if you look, they give you a sequence, not an equation. So this says your sequence. So 1, or A1 is 1, A2, so the second number is 3, A3, or the third number is 5, fourth number is 7, fifth number is 9. So if you notice, you can actually notice a pattern, all right? This pattern is you are adding 2 to get to the next number, all right? So our explicit formula, all right, that we get from the sequence is called A sub n is equal to 2n minus 1, all right? So your n, that's what number term. So number term, and A sub n means the term you want. The term you want. The 6th term, or the 7th term, or 8th term, or the 9th term, whatever. So how you figure these out, if you were to just be given this right here, how you can figure out what your values are, is if you wanted the first term, 1 goes in for n, and 2 times 1 is 1, minus 2 is 1. And 2 goes in here now for the second term. 2 times 2 is 4, minus 1 is 3. And 2 times 3, because the third term, 2 times 3 is 5, 5 minus 1 is 5, or sorry, 6, minus 1 is 5. The fourth term, so 2 times 4 is 8, minus 1 is 7. And then the fifth term, 2 times 5 is 10, minus 1 is 9. Now notice, that's how you get those numbers. You actually were given those numbers from the sequence. You'll either be given one or the other. You'll either be given this guy or this guy. One or the other. One or the other. And that's how you figure out your terms. So, what you do is you use this like a coordinate. All right? So, this is like a coordinate here. 1, 1, 2, 3, 3, 5, 4, 7, 5, 9. So you're just going to plot those. 1, 1, 2, 3, 3, 5, 4, 7, and 5, 9. Now, because this is our sequence, we know that you can keep going up and your difference goes downward as well. You can still, if you were to get like negative n values, like the negative first term or whatever, you would get all these values that are down here. Now, here's the deal. You cannot get decimal terms, right? You cannot get like, oh, my 6.5 term or my 4.75 term. No. So in here, there are no decimals. All right, so no decimals as your n value. Your n can be no decimals. It's got to be whole numbers. So this is going to be a discrete function. It's discrete. Your common difference is 2. You're going up by 2, just like the last one. But here's the difference now. Your domain is not all real numbers. It's, if you look at this, because we went negative and positive, it's dot, 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 right? Because you could go negative. We got 1, 3, 1, 2, 3, 4, dot, 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 okay? And your range are your y values, so dot, 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 all right? It's 1, 3, 5, 7, 9, dot, 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 because that's what it looks like. And those are supposed to be brackets. Those are just really bad looking brackets, all right? So that's your domain because it is discrete. So along with adding and subtracting, you can also multiply. So this first one up here, now after you flip the page, this is called an explicit exponential function because, well, this is exponential, all right? And what we would do is we actually would take this and put this in our calculator, all right? So where's my calculator? Oh boy, it's gone. Well, our calculator would give us these values, right? So I would type this into my calculator and I'd get these values for x and y. So I'd start at 0. So 0 would give me 1, 1 would give me 2, 2 would give me 4, 3 would give me 8, so on and so forth. Like 4 would give me 16, and you keep going on and on and on and on and on. Now, because this is an equation, all right? It's an equation here. You actually can get decimal values, all right? So when we plot these points, like 0, 1, 1, 2, 2, 4, I went up a little far, 2, 4, 3, 8, 4, 16. I think this is 16 up here. If you notice, whoosh, this thing's going to keep going. It is continuous. It's a line, all right, because this equation allows decimal values. All right, our common ratio, or our growth rate, is multiplied or times 2. All right, our domain is all real numbers, and our range is all real numbers, because again, it's exponential, or it's a line. Oops, sorry, hold on, check. I gotta erase this. All right, I gotta erase this bottom part. Here's the deal. There's an asymptote here. All right, your range is y values that are greater than 0, because you will have an asymptote here. You can, even with decimals, it still will ride along this. So you cannot get a range any bigger than 0 for this one. Now, this second part over here, this is going to be a little bit more. This is called an explicit geometric function. And the reason I know this is because if you look at these numbers, 2, 4, 8, 16, and 32, you can tell that these are multiplied by 2. All right? It's multiplied by 2. Multiplied by 2. Multiplied by 2. Multiplied by 2. All right? And the explicit formula is this. You'll be given one or the other. All right? Now, just so you can kind of see how this goes, notice that there's something a little different here. See this n minus 1? All right, n minus 1. So you're going to take your number term that you want. So say you want like the first term, you're going to put a 1 in here. All right, you put your number in there that you want. So to figure out these values, if they didn't give you these and you had to find them, you're just going to take these 1s, 2s, 3s, 4s, and you're going to put them in here. 1, 2, 3, 4, 5, and you're just going to evaluate. All right. When you put those in your calculator and you were to evaluate, you would get the same numbers. You get 2, 4, 6, 8. 2, 4, 8. Good Lord. 16, and then 32. You would get those same values that we got up at the top. So, again, you can plot those. All right. So 1, 1, 2, 2, 4, 3, 8, 4, 16. But notice there's no line because you cannot have decimal terms. So it's discrete. Your common ratio, it's times 2. Our domain, all right, our domain here is going to be, because you can't have negatives for x values, ... 1, 2, 3, 4, ... because you can have whatever. And your range values, all right, ... because it's going to follow the same pattern. 2, 4, 8, 16, ... And that's your range. Okay? So some of that should have been a repetition, but for the majority of you, that second part of each of those is new, and that's what we're kind of be working on today. Working on those, not necessarily graphing them, but picking out patterns and writing out formulas. All right, here we go. All right, so now you're going to be writing down these things. So I said you haven't heard these words before, and you haven't. So these are the new terms. So you have arithmetic and geometric. These are your new terms. Arithmetic and geometric sequence. That's what we're going to be talking about today. So arithmetic means you can add or really subtract from one number to the next. All right? So you're adding or subtracting to get from one number to the next. So it says positive or negative. Really, if you're adding, your number is going to be positive, you're going to be going up. Negative means you're going downward. All right, so what you're going to need to start being able to do is look at some terms. So you got to be able to look at this set of numbers and say, all right, is this arithmetic or geometric? We'll first start off by saying, do you notice like a common addition, like a common number that we're adding to? Well, how would you know? Well, take the second number, 4, and then subtract it from the first number, 1. 4 minus 1 is 3. Then do that again, but take the third number, 7, and minus from the second number, 4. 4 minus 7 is 3. Oh my gosh, they have a common number here. So that means to go from one number to the next, we are adding 3. It's a plus 3. You're adding 3 to get to the next number. 1 plus 3 is 4. 4 plus 7 is, or 4 plus 3 is 7. 7 plus 3 is 10, so on and so forth. If you look at the second one, we're going to do the same thing to figure out our common difference. You take the second number, so 1, and you subtract it from the first number. 1 minus 5 is negative 4. So you do that again. We're going to go negative 3 minus 1. Negative 3 minus 1 is negative 4. That is your common difference, negative 4, which means you're subtracting 4 to get to the next number. That is called arithmetic, like arithmetic, adding and subtracting. Geometric is when you multiply or divide. Really just multiply, because dividing is just multiplying by a fraction. So we really don't want to say dividing, but you just multiply by a fraction. So the fraction means like divide. We really don't call it. We just say you're multiplying by a fraction. Now how you do that is almost the same thing. You take the second number, 4, and you go 4 divided by 1 is 4. And then you do it again. Take the third number, 16 divided by 4 is 4. This is your common ratio, 4. You really multiply by 4 to get to the next number. 4 times 4 is 4. 4 times 16 is 4. Or 4 times 4 is 16. 16 times 4 is 64, and so on and so forth. Here, for this one here, you do the same thing. Take the second number, 30, and divide it by the first number, 60. 60, or 30 over 60 is 1/2. And you do it again. All right, 15 and 30. 15, third number, divided by 30, the second number, is 1/2. This is your common ratio, 1/2, which means you multiply by half or divide, and that gives you your ratio. Now, the domain for the sequence of the set, right? So your domain is just all of these numbers. So when you do any of these, you just write out your numbers. So like the domain, right, would be 1, 4, 16, dot, 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 dot. All you need to do is like 3 or 4 of those just to show what the number is, and dot, 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 showing that it goes on forever. Okay? Or in this case, because that was it and there was no dots, notice how in this problem there weren't any dots up here. Where is it? 1, 4, 16. I was doing this one. Oh boy, just erased that. Okay, awesome. Notice how there's no dots here. All right, so you actually need to write them all out. 64 and 256. If there are dots to show that the series goes on forever, well, then you need to show for the domain and the range that it's dot, dot, dot. Okay? Alrighty, here we go. So again, if this feels like it's going really, really fast or really, really slow, you can always pause, right? You can always pause this thing to make sure that you're understanding what's going on. All right, here we go. I wonder if this is charging. Is this charging? Okay, it is. All right, here we go. So I look at number 2. I got 2, 4, 6, 8, 10. Well, that is an arithmetic. You're adding by 2. And if you're like, how did you know that you're adding by 2? Take the second number, 4, and subtract it from the first number. Always start by adding and subtracting. So 4 minus 2 is 2. Take the third number, 6, minus the second number, 4, and you get 2. Well, clearly you're adding or subtracting. You have to determine that. So that's 2, and it's a common difference of plus 2. You add 2 to get to the next one. Now, all right, here we go. So what we have to do in this problem is determine if the series is arithmetic or geometric, and then determine the common ratio. So that's what we did. We will come back to this. We will come back to this. Do not fill that out, okay? Don't fill that out for any of these. So all we're going to do, arithmetic or geometric. So number 2, all right? Well, if I look, all right, start with the arithmetic, all right? So we'll go 5 minus 1 is 4. 25 minus 5 is 20. Oh boy, these aren't the same, so it's not arithmetic. So let's check geometric. 5 divided by 1 is 5. 25 divided by 5 is 5. Oh man, it is geometric. So it would have a common ratio, not a difference, of times 2. Multiply by 2. And again, wait on this. All right? So why don't you try 3, 4, 5, 6, pause it, try it, and then you can check my answers. All right, so here we go. So this next one is arithmetic. It's a common difference of minus 3, right, because you're subtracting 3. Number 4 is a multiplier, so it's geometric. So geometric, and your common ratio is multiplying by negative 3. Right? And I know it's negative because it's changing the numbers. Positive, negative, positive, negative, positive, negative. Number 5 is arithmetic. And our common difference, because you're adding and subtracting, is negative 4. You're subtracting 4 to get to it. And then lastly, number 6 is geometric. And your common ratio is 1/2, because really you're kind of almost dividing by 2. So now let's go to our book. So take out your book and we're going to turn to page 85. All right, so it says complete the sequence by using recursion. What are the 5th, 6th, and 10th terms of the sequence? So if you look here, all right, they want you to first determine what is the pattern. So if they give you a set of numbers like this, all right, you can actually determine what's happening, whether it's arithmetic or geometric, by looking at the terms. So if you look, 5, 9, 13, 17, those numbers are all small, so it's probably doubtful that it's going to be geometric. It's probably going to be arithmetic, but I check it nonetheless. So 9 minus 5 is 4. And then 13 minus 9 is 4. So this is definitely arithmetic. All right, and your difference is 4. So a common difference is adding 4. So first determine the pattern. I did. Common difference of 4 is arithmetic. So let's find the 5th term. So a sub 5. So basically, since you're adding 4, you're going to go 17 plus 4. 17 plus 4 is 21. And then a sub 6, well, that's just adding 4 again. 21 plus 4 is 25. Now, how do you find the 10th term? So a sub 10, again, you add 4 again. 37 plus 4 is 31. And that's how you do it. Now, some of you are like, oh my gosh, that's really easy. That's awesome. So let's go back to our notes. And let's make this a little more challenging now. So let's write this down on your paper. All right? So write that down, pause it, but I'm going to keep going. So a recursive formula, which is the second and last new thing, all right, is the formula that basically tells you what's happening in your series of numbers, what's happening to get to the next number, all right? So in a recursive formula, n means your term number. So what number? The first, second, third, fourth term. N minus 1, and usually that's in parentheses, is the previous term, the last term, all right? Now, a recursive formula uses the previous term within the formula. So in order to get to the next term, you have to use the last term that you have. So in an arithmetic, so when you add or subtract, all right, this is your recursive formula, which means to find any term number, a sub n, it's equal to your last term plus your difference. So plus 3, plus 7, minus 2, minus 8. A geometric is when you multiply, and really that's all I want you to think about is think about multiplying, either by a fraction or whole number. And you multiply to get to the next number. So it means the current number is equal to the last number times your ratio. So times whatever you do to get to the next one. All right. So, all right, that's what a recursion formula is. So let's go back to the first 6 examples up at the top here. And let's try to create a recursive formula. Now, since we've already done this, you need to actually do this in order to do the recursive formula. Arithmetic means that you need your last term. All right, so what you do is you write out a sub n minus 1. All right, so it's a sub n minus 1, and then add your difference in. So it's going to be plus 2. All right, that's what it is. Now that n minus 1, this guy right here, this is really tiny. You want to write that kind of almost like an exponent, but at the bottom. All right, so that's what it is. It's a sub n minus 1 plus 2. Number 2, it's geometric. So it's a sub n equals a sub n minus 1 times 2. Right? So times 2. Or usually sometimes you'll see it like this with a parentheses and a 2, or a dot 2. All right? So it means the same thing. Number 3, all right, it's a sub n minus 1, and then because it's common difference, you're just going to put minus 3. All right? You guys catching on what's happening here? So for all of these, you're going to go a sub n equals a sub n minus 1, and notice I did a capital A. All right, doesn't matter. All right, and then we said it was times 3, so I'm just going to go times, times a negative 3. Number 5, all right, your recursive is a sub n equals a sub n minus 1. Again, doesn't matter whether you do caps or the that little squiggly a, whatever, all is the same thing. And then we're going to do minus 4, because that's what that was. And then lastly, we're going to do a sub n equals a sub n minus 1, and then times a half. And again, recursive formula is just saying, how do you get to the next number? So, going back down here. All right, let's do example 2 and 3 in the book. All right, so here's 2 and there's 3. So again, if I'm going fast, pause it. If I'm going slow, no, pause it, whatever. Here we go. Find the missing terms in the sequence using recursion. Write the recursive formula. So, all right, if you look, they want you to find 5, 6, and 7. First, you have to determine what's happening. So I would start with arithmetic. I take the second term, 13, and subtract it from the first term, and I get 5. Okay, so there's a difference of 5. So I take now the third term, 18, minus the second term, 13. Now I get 5. Oh man, they have a common difference. So this is arithmetic. All right, our common difference equals plus 5. And you actually could write the recursive formula right now, which is a sub n equals a sub n minus 1, then plus 5. And usually I try to make that plus 5 really big, because that's my recursive formula. So how do I find 5, 6, and 7? Well, I just add 5. So a sub 5, so 23 plus 5 is 28. A sub 6 is 28 plus 5 is 33. And a sub 7, 33 plus 5 is 38. Now, I want you to try 3. Pause it, try it, and then see my stuff, okay? All right, so this, hopefully you figured out that it's geometric, right? And you did that by, well, adding first and realizing that they don't add to the same numbers. But if you go 18 divided by 6, it's 3, and 54 divided by 18 is 3, which means this is a geometric, and our common ratio is times 3. So your recursive formula is a sub n equals a sub n minus 1 times 3. It should be n minus 1. Come on, man. N minus 1. That looks terrible. Let me erase that. I'm sorry. That looks like absolute garbage. Here we go. There you go. Awesome. All right, now, to find your next terms, all you do is you just multiply by 3. So to find your fifth term, a sub 5, you take your fourth term, so 162, and multiply by 3. Oh boy, don't have my calculator. Hold on. Get your calculator really quick. Forgot I'm going to have to do some math here. $162 times 3 times 3 times 3 times. All right, so your fifth term, when you multiply 162 times 3 is 486. Your sixth term, because you take 486 times 3 and you're going to get 1,456. And then a sub 8, so you have to take 4,374, multiply that by 3, and you get 13,122. There you go. That's what you do. All right, so we got a couple more problems left to do back on this worksheet. All right, so if you look, all right, we can do some extra stuff here. All right, so if you look in number 7, it says a sub n equals a sub n minus 1 plus 6. So it's basically saying here, it's giving you the recursive formula, it's telling what's happening. We are adding 6 to get to the next numbers. So if a sub 2 is 4, what is a sub 4? Well, what I do is I say, all right, a sub 2 is 4. I write it like this. A sub 2 is 4. A sub 3, I have no idea. And a sub 4 is what I want to find. So I take this plus 6, and I go, all right, here, plus 6. So 10 plus 6, or 4 plus 6 is 10, plus 6 is 16. So a sub 4 is 16. So a sub 4 equals 16. So basically, I just write out a list to kind of help me figure out what's going on. Number 8, if you look, it says a sub n equals a sub n minus 1 times 3. So I multiply by 3 to get to the next number. So if a sub 5 is 7, a sub 6 would be 7 times 3 is 21, and then a sub 7, which is what I want, is 21 times 3, which is 63. So a sub 7 equals 63. All right, see that? So that's how you can use that material. So, all right, here we go. These right here are just extra problems for you to go through. All right, I want you to pause. I want you to try to work on these, and I want you to take a look at the answers that I'm going to put up here, okay? I only want you going 9 through 14. We will not do 15 or 16, all right? Just 9 through 14. All right, so pause it and try to do those. All right, here we go. So I'm just going to put arithmetic, A-R-I-T-H, so arith. All right, our common difference is we're adding 3, so it's a sub n equals a sub n minus 1 plus 3. All right, this is geometric, geo, and your common difference, or common ratio, sorry, is times 3. So a sub n equals a sub n minus 1 times 3. Here, this is geometric. Geo, your common ratio is 1/3. So it's a sub n equals a sub n minus 1 times 1/3. This is arithmetic. Your common difference is minus 7. So it's a sub n minus 1 minus 7. Alright. Number 13, notice right away it's positive, negative, so it must be geometric. And it's a multiplication of a negative number, so common ratio is going to be -2. A sub n equals a sub n minus 1 times -2. And then lastly, this is arithmetic. And your common difference is -7. So you're going to do a sub n equals a sub n minus 1 minus 7. So, all right, you have seen everything. Hopefully you're doing really well. Once you're done with this, go and ask this up for the homework, all right? You should do really, really well on it. If you have any questions, you can come and see me on Tuesday morning or talk with Miss Sanders if she's in the classroom. All right, have a great day. Be good to the sub.